In this example, we're going to answer a quote-unquote Ferris wheel question. Suppose null is on a Ferris wheel, and we know the radius of the wheel, we know where the bottom of the wheel is, and we know how long a revolution of the wheel takes. We know where she starts on the wheel, and we want to know her elevation at certain times, and also when she reaches certain elevations. Okay, so um, the height of a rider on a Ferris wheel over a period of time is sinusoidal. So what we're going to do is we're going to draw a Ferris wheel that has a radius of 8 and a bottom that's 2 meters above the ground. So here's a height of 2 meters. Since the radius is 8, we know that the diameter will be 16, so the top of the wheel will be 18 meters above the ground. Okay? Now that means the middle of the wheel is going to be 8 meters above the bottom and 8 meters below the top. So the middle of the wheel is going to be 10 meters above the ground. Now, since she starts at the bottom, we know she starts at the bottom of the wheel and goes up. Well, that means as she goes around the circle one time, her height as a function of time is going to look like this. Okay? And that's what we show on the next slide. Now, we have our dependent variable, which is height, here in the y-axis, but we need an independent variable, and our independent variable is clearly time. Well, what's the period? The period is 3 minutes. And what is 3 minutes converted to seconds is 180 seconds. And that's going to give us a bit more accuracy, perhaps. So we're going to put 180 seconds down here, and we're also going to make note that what we've got here is a periodic function with a parent function of negative cos x. Okay? Now, we've got our curve set. We're going to determine the equation of that. We see here that our phase shift is 0 because the first the x coordinate of the first point of the negative cos cycle is 0. Okay, so d is 0. That's our phase shift. Our period is 180 seconds, the horizontal distance necessary to do one cycle. That's 180 seconds. So in these word problem contexts, we can make k positive if we're choosing appropriate parent functions and phase shifts. So we're going to make k be positive, and we're going to say that k is equal to 360 degrees divided by 180 seconds. Now, we could say that k is equal to 2 pi over 180 seconds and simplify that to pi over 90. But let's use degrees here. Let's put our calculator in degree mode, and rather than having an irrational number for k, that would be an irrational number. Rather than doing that, let's not use radians, let's use degrees. Say 360 degrees over 180 seconds. And that's going to give us a k value of 2 degrees per second. But for simplicity, we'll just say k equals 2. The units will work themselves out, so long as we continue on using seconds as our time. Okay, now the amplitude is 8 because the maximum y value is 18 and the minimum y value is 2. And 18 minus 2 quantity over 2 is equal to 8. And since the parent function we're using is negative cos x and the amplitude is 8, we're going to say a is equal to negative 8. The axis of symmetry is going to be denoted by c. Well, that's the middle y value. We can tell by observation that it's 10, but if you can't tell, then what you do is you take the maximum y value, add the minimum y value, and then divide that by 2, and you end up with 10. And so putting all of that together, we have a cos of k, t minus d, t is our independent variable rather than x, and plus c. And since we've got 2 times t minus 0, we can just call it 2t. Okay? And we've got an equation for our curve. Well, that's awesome. So now for part A, it says at a time of 38 seconds, what is her height? What's her elevation above the ground? Well, all we have to do is plug in 38 for t. 2 times 38 is equal to 76. So our order of operations is to determine the cos of 76. and then multiply that by -8 and add 10. And when we do that, we get approximately 8.1. So what that means is that at roughly 8.1 seconds into at 38 seconds into the ride, Nala's elevation will be approximately 8.1 meters. That, believe it or not, actually makes sense. Just take a look at this curve for a second. Halfway through the ride, when she's at the maximum, that'll be 90 seconds. Halfway through that first half will be 45 seconds and will be 45 seconds into the ride. Well, at 38 seconds, which is right about here, we can calculate her height, and it'll be somewhere in between 2 and 10, right about there. I haven't drawn it particularly well right now, but it's actually at 8.1. And so, according to our graph, it actually makes sense. That's where she should be. Okay, now we want to know when the first time is that her elevation is 15 meters above the ground. So what we're going to do is we're going to let 15 equal h at t. And then we're going to solve. First thing we do is we subtract 10 from both sides, and then we divide both sides by -8. And we end up with -5/8 equaling cos of 2t, which means that 2t is the cos inverse of -5/8. When you look at a sentence like this, you have to know what the angle is. The angle is the thing that the trig function is operating on. In this case, the trig function, cos, is operating on 2t. 2t is the angle. So the cos of 2t is -5/8. So when I cos inverse both sides of this, I end up with 2t and the cos inverse of -5/8 on the other side. So what is the cos inverse of -5/8? Well, we know how to do this from an earlier section of the course. The cos inverse of -5/8 is 128.68 degrees or 231.32 degrees. Because there's no phase shift in this question, in other words, because right down here the d value is 0, there's no phase shift. That means that the first positive time will be at the first positive angle. So that's a pretty good thing to know. So this question is actually kind of nice when there's no phase shift. So what we know is that this value right here of the angle, 128.68, that corresponds to the first time that Nala is at the height, the elevation in question. Well, the angle was 2t1, was 2t. So since that means that 2t is approximately equal to 128.68. So since that's the first positive angle, then it's also the first positive time. So we can say 2t1 is roughly 128.68. In other words, the first positive time. So dividing both sides by 2, we see t1 is roughly 64.34. So the first time she's at a height of 15 meters is at approximately 64.3 seconds. Now, let's just ask ourselves, does that make sense? Well, we already said that halfway through here is at 90, and halfway through that is at 45. Well, for her to reach 15 meters would be right about here, coming across and then dropping down and finding the corresponding time. It makes sense that we would say that that time is roughly 64.3. So we see our graph is actually coming in handy to help us interpret it. Now, some people don't like saying 2t1 is 128.68. They find a little bit of difficulty in saying the angle is 2t. So for some people, and there's nothing wrong with this, what they do is they say, let theta be 2t. So some people see it easier by saying, let theta be 2t. Then what we're really solving is -8 cos of theta plus 10 is equal to 15. Okay, so we're just going to solve this out. And what they do is -8 cos theta plus 10 is 15. They subtract 10 from both sides, and then they divide both sides by -8. And then they have cos theta is equal to -5/8. Well, that to them is a little bit easier to figure out. They say theta 1, the first theta, is roughly 128.68 degrees. But then they say to themselves, hey, wait a second, what was theta? Theta was 2t. We said that a minute ago. So that means 2t1 is 128.68, meaning T1 is 64.34. So for some people, it's a little easier to go through that substitution step, but it's not necessary if you don't need it. Now, we want to know when the fourth time is that null is going to be at the height in question. Well, when there's no phase shift, the first time's at the first positive angle, the second time's at the second positive angle, etc. So the fourth time will correspond to the fourth positive angle. We need to find ourselves the fourth positive angle from our earlier calculations. So recall from part B that we figured out that the first angle was 128.68. Remember, we're talking about cos of 2t equaling negative 5/8 from a while ago. That's what happens when the height is 15 from our earlier calculations. So the first positive angle is here, the second positive angle is here. Well, if we add 360 to each solution, we see that the fourth positive angle will be 591.32. The first one's at 128.68. The second one's at 231.32. The third one's at 488.68. And the fourth one's at 591.32. So that means 2, remember the angle is 2t. So 2t4 is equal to 591.32 roughly, so t4 is roughly equal to 295.7. Okay, well, that's good to know. The fourth time null is at that height is roughly 295.7 seconds. But again, some people don't like thinking of it that way. So instead of coming up with, instead of saying that negative 8 cos of 2t plus 10 equals 15, like this, instead of saying that equals 15, some people say negative 8 cos theta plus 10 equals 15. Then, when they do their calculations, they come up with the fourth positive angle equaling 591.32. Then they remember theta is equal to 2t, so 2t4 is roughly 591.22, meaning that t4 is roughly 295.66, or as we said here, 295.7. So if you want to introduce a new variable called theta for your angle of 2t in this question, do it. If you don't need to, don't worry about it. So, and there are also other ways of looking at that situation. Because of symmetry, there's different ways that people see symmetry. So there's other ways of getting the correct answer here as well. Now, the next question says, what if the ride lasts for 2 full revolutions? How much total time would Nala spend at or above 15 meters in elevation? So to answer this, what we can do is extend the curve for 2 full revolutions, and let's see what happens. So this is the curve that we had on the previous slide. We did 1 revolution. Well, now we're saying let's do another revolution. It'll look exactly the same, and it'll go an extra 180 seconds after the first period, so it'll go up to 360 seconds. So what we're looking for here is, when is she at 15 meters? Well, she's at 15 meters right here, and right here, and right here, and right here, and those correspond to these times down here on the horizontal axis. So she's above 15 meters when she's at this first hump as well as at that second hump. So the length of time is represented by the length of the x-axis when she's above those values. So we've actually already done all the hard work. We already figured out that all these angles, and that's a good thing. So hopefully what you can see is the time above on this first hump is represented by T2 minus T1, and the time above on the second hump is represented by T4 minus T3. Okay, well, go back to these angles that we had from earlier. Each one of those angles represents 2t. So the first t is equal to the first angle divided by 2. The second t is equal to the second angle divided by 2. The third t is equal to the third angle divided by 2. And the fourth t is equal to the fourth angle divided by 2. And we get those times shown there. And so now T2 minus T1 quantity plus T4 minus T3 quantity is equal to what you see shown, roughly 102.64 seconds. So that's the answer to the question. She's above a height of 15 meters for roughly 102.6 seconds. Now, some of you might say, wait a second, couldn't we have just evaluated the first T2 minus T1 and then multiplied that by 2? Because the symmetry of the circle suggests that this distance is actually going to be equal to this distance. So we can just figure this out and divide and multiply that by 2. And absolutely, that's totally correct. And to blow your mind a little bit further, what you could even have done is said this. Right there, where I'm drawn, is 90 seconds. Well, whatever this is equal to is going to equal this, symmetry of a circle. So we can take this value, multiply it, the horizontal distance from T1 to 90, and then we can multiply that by 2 to get the horizontal distance from T1 to T2, and then multiply that by 2 to get also the T3 to T4. So in other words, we could just figure out this horizontal distance right here, the one I'm pointing to, just figure out that horizontal distance and multiply it by 4. And that would also be a valid way of looking at it. And like I said earlier, there's different ways of looking at it when symmetry is involved. Now, if the rider starts at the bottom of a wheel in a Ferris wheel question heading up, the parent function will be negative cos x. If a rider starts at the top of the wheel and heads down, the parent function will be positive cos x. If a rider starts at the middle of the wheel, then you need to know if they're heading up or down to start. If the rider's at the middle of the wheel heading up, the parent function will be y equals sine x. But if they're starting at the middle of the wheel and heading down, the parent function will be negative sine x. And it's important, obviously, to know your parent functions in order to be able to answer the question. But once you know the parent function, all of the questions have striking similarities.